Hello, everybody, and you're most welcome to this studio. Today, we're in Halmstad, Halland, the birthplace of Per Gessle, I believe. And we will talk about mobile processing architectures and devices. And with me within the studio here at Halmstad University, we have Yusra Al-Kabani
Yes.
and Liang Liu.
Yes.
Did I get it right?
Yes, perfect.
Perfect. Both associate professors.
Yes.
You in Lund?
I'm at Lund University.
Yeah.
Yeah, and Halmstad University.
Halmstad.
Yeah.
And do you collaborate?
Yes.
Within ELLIIT, yes.
Yes.
Within ELLIIT?
Yes.
Okay. So what kind of projects are you doing together?
So we are doing baseband processing for the next generation wireless communication systems.
Okay.
So we are developing hardware for the 6G.
Yeah. And how many are you within this research project?
Well, I think we collaborate also with another team in Linköping, but we have 3 other persons in Halmstad working with me in my team.
Yeah.
And
You have some people around you as well.
Yes, it's different work packages in ELLIIT, so
Okay.
it's connected.
Oh, great. So, and we have Shanghai, and we have Cairo in Egypt,
Yes.
and then we have Anders Berglund. What can you contribute with? We have Shanghai and we have Cairo. You can say.
Well, I'm much more of a local kind.
So,
I could,
where do you start?
Malmö and Lund, would I say.
So you're
the Malmö
okay.
guy.
That's an area I know. Okay, good to have you with us, Anders Berglund. For those who don't know, you do plenty of stuff. I believe you're both an entrepreneur, you're a strategic advisor, and you've been at the board member at LTH in Lund as well. And,
Yes, that's correct.
And what have I forgotten?
Well, I'm involved in a couple of interesting tech companies in the region here. Yeah. I'm formally also actually in the board of Skissernas Museum.
Okay, great.
University, so it's also part, and Historiska Museet in Lund.
Okay, so, well, history and art. And this area, we're talking about mobile processing architectures and devices. You mentioned some startups, some small companies that are quite inspiring. Can you tell us about your that area?
Well, currently I'm very active and involved in a company that I had the pleasure to co-found together with some of actually Professor Liang's colleagues, Babak Mohammadi and Joachim Rodriguez. And we do, it's based on Babak's research at the electrical engineering EIT department actually at Lund University in extremely power efficient on-chip memories. Those are the small memories that reside on inside the integrated circuits like CPUs and GPUs and this type of circuits.
Yeah, and so it's all about the efficiency, I believe.
Extreme power efficiency, but also actually extreme high speeds in frequency.
So what about the since you're very more efficient with this? What about these kind of new inventions? How does that affect when it comes to cooling? Because that's the major problem in many ways.
Yes, and I believe memory actually is helpful in terms of cooling if it's very power efficient. Because as Anders said, memory occupies a large area in the chip. And then if it's not that power hungry, it's helpful with the power density, and then it can helpful with the cooling, I believe.
So this kind of technology, what would that enable in your research?
Yeah, as we discussed in our presentation, actually one of the main bottleneck in today's processor is the memory, is how to move data from the memory to the processing unit. Actually, this is the bottleneck for both power consumption and speed. So we actually require high speed and low power memories in our processor, and it's really helpful.
And this kind of new inventions, will this be a major part of the core of the development that will come?
Sure, definitely, because memories are a very important part of any computing system, right? Even a human being, we always say, if you remember, then you are 50% smart, right? If you don't have good memory, then you lose 50% of your intelligence. So memory is very important for a computing system, and definitely is an integral part of any new computer architecture.
And what can you say about what are the relationship between memory and battery life?
Well, since memory consumes a lot, like a big chunk of the power that is consumed by the overall system, if you reduce the power consumption of memory, then the battery life will be longer, definitely.
Yeah.
Right.
Anders, what can you say about the relationship between memory and battery life?
Well, I mean, it is if we drastically reduce the power consumption, as I say, of the total circuit, of course, you prolong the battery lifetime. And that's for all battery-powered circuits, our memory contributes a lot to the battery lifetime.
And what will happen with will we have the same sizes of the batteries, or will we get smaller batteries from this, or will we keep the size and get more battery time? Do you see what I'm aiming at, Anders?
I'm not sure that I can really answer that question in a good way. I think we have other experts here. But I mean, to rephrase what I just said previously, I think that the battery lifetime is always important. I think power is always important. Each circuit designer is always chasing the lowest possible power, especially if it's a battery-powered system. Even if you make a small, everyone have their power budget. Even though, as you understand, if you switch on the display will consume enormous amount of power in a mobile phone, for instance. That doesn't mean that you don't care about the other components. There are some components that will always be on, even if the phone is off, to detect if you're like moving it or and this type. And even though they do not consume a lot of power, it's the constant power drain that matters. So how that impacts the battery size, etc. I think you would like the battery to last as long as possible. You don't want it to be super huge if you don't need to. I don't know if that gives you. I mean, it's not a straightforward answer to your question. So it's more.
Let me take this technology, or the talking about the efficiency. Will this be the same when it comes to the big? If we say the mobile system or stationary data centers, will we have the same effect?
Yeah.
Think?
I think different applications have different requirements in terms of power consumption. As Anders mentioned, we would like to reduce power consumption as much as possible. And then I believe it's the total energy that matters in the end, because it's power multiplied by time. Even if your mobile phone is not working, it's leaking. So the leaking power for memory and then processing unit is also important. And I believe the new memory technology should also be able to reduce the leaking power. And then if we push to the extreme, the IoT devices, we even envision that the devices without battery, which means that we can do wireless power transfer to those devices. That saves a lot in terms of chemical recycle of the batteries.
So how will this affect me as an individual? I have my cell phone. What will be the future? What can you see? From examples like Anders or others?
You don't have to charge your phone every night, maybe.
You think so?
Hopefully. I think when you buy a new phone nowadays, you can use it for a couple of days without recharging it, especially the bigger sized phones, because they have bigger batteries. For example, the iPhone.
Yeah.
There are 3 different sizes of the iPhone, and you would imagine that the smaller one will consume less power, so it can live longer. But if you check, because the larger one has a larger battery, usually it has a longer battery life. So, and they can fit a bigger battery because it is big. It is a big phone, right? So it's not always that you want to make the battery smaller. You were asking earlier about the size of the battery. So sometimes you just don't want to have a big battery because you need the device to be very small. In this sense, you want to be able to be power efficient so that you can achieve a lifetime based on a small battery. But if you don't care about the size of the device, you can have a larger battery and consequently larger battery life, right? And also, I think you were asking about data centers and the impact of that. Even data centers need to reduce the power consumption. Although they will not work on batteries, they will actually have a power source, right? Usually you don't want to run a data center on a battery. But it consumes a lot of energy, and you want to reduce the energy consumption in data centers too. So if this
And then you won't need the cooling in that much.
Or less cooling would be needed. Or you can even add more processing power. For example, if you check supercomputers, one of the competitions between supercomputers is how much energy they consume, right? And how many cores they have, because this will give them the computational power. And usually there is a list called the top 500 that lists the most powerful supercomputers in the world from all over. And the fierce competition is usually between the US and China, usually. And the big advantage, for example, in the US supercomputers is that they don't consume much energy. So I think Chinese computers are very powerful, but they consume more energy, and that's a disadvantage.
So Anders, what's your perspective? For me as an individual, how will this affect me, these new technologies?
You mean with a increased capacity, or with a
I mean,
power?
I have my cell phone, I have my computer. Will this? What will this enable?
But I think, I mean, in the end, it enables a more powerful phone, probably, because in the you will higher resolutions, which already today is quite insane in a mobile phone, and which requires quite a lot of computational power as well, because you have so many millions of pixels that needs to be updated 60 times a second, and even I think today it's up to 120 times a second if you really look on a phone. So it's a huge processing. So you would get in the end, I think you would feel that you have a better product, which is very subjective. What that is, that can do more things for you. But in the end, it's I think the user experience will be better.
Yeah. And we talk about the IoT, Internet of Things, in some, and we will have more gadgets, more connected, things around us. Will this be, is this necessary? Forget that technique, developing. What do you say?
Yes, I think for IoT devices, power is even more important, because you don't have space to install batteries, or you even don't have space at all to install batteries. So power efficient is very important.
So how do they get, they need some power.
They can do power harvesting, for example, from the radio signals. So that's one way to do it, like those wireless
through
tags.
radio signels, they get their power, and then they're very efficient, so that will be enough.
Yeah, we hope so. That's our target.
Yeah. When it comes to IoT, your thoughts?
Well, IoTs should, since you implement networks of thousands and sometimes millions of devices, you want them to be as cheap as possible. And cheap means also consuming less power. So I think this technology, if it is cheaper than other technologies and consumes less power, then basically it will lead to more efficient IoTs, right?
Yeah. So what actually in these, let's say, IoT gadgets, and what in them really needs the most power? What do they need the power for? What are the core? Do you understand what?
Yes.
Yes.
Yes. So I think, of course, an IoT will have a processing system. So it will have memory, and the memory consumes a lot of power. But they also are connected to sensors, and those sensors will also consume power.
So it's the memory and the sensors that need the power.
And the processing system, of course. I mean, every part of the circuit will consume power, but if you look at percentages, I think mainly the memory and the sensors consume a lot of power, and it can be optimized.
Yeah.
Yeah.
If you should optimize IoT things, Anders, where would you put your main effort?
I mean, from our perspective, and it would be, we contribute by a much less leaky memory and a much less, or they're also reducing the dynamic power consumption in the IoT device. So we would help to prolong the lifetime of this. I think that, just to give just an example, that there is a standard called narrowband Internet of Things, and I think they have a 10-year. According to the standard, you must be able to run 10 years with like 2 standard batteries inside them without being recharged. So the idea is that you should be able to deploy this type of IoT devices everywhere, and they connect to the grid through the traditional base stations. And for them, of course, to be able to run have a lifetime of 10 years before changing the batteries requires extreme low power consumption.
Yeah.
And that's help with our.
Yeah, I can add on top of the sensor processing and the memory, actually communication between the IoT sensors with the base station also consumes a lot of power, which means that we need the next generation wireless systems to help with that.
One thing I'm thinking of, when you have different techniques, don't they interfere with each other when they are put together in a small surface? I mean, we have Wi-Fi, Bluetooth, both 5G. Don't they struggle if you have many different techniques? Is that a problem?
Yeah, I mean, basically different technologies are using different frequencies to communicate, that they're separated in the frequency band. Like we're driving the highway, we're driving different lanes. But then if we really would like to use those frequency band more efficiently, there are licenses band that or the systems can use. So that you will require, as you mentioned, very smart interference cancellation detection techniques to use those bands.
And do we have those techniques?
Researchers are working on that.
Okay. Any more perspectives on that?
No, I think the problem of collisions and interference is being studied extensively by lots of researchers. It exists, but as Liang mentioned, if you are using different technologies, then different technologies should not be an issue together as long as they use different frequency bands. The problems happen when you share the frequency band. Then you need the techniques to avoid collisions and interference.
So we're all into the efficiency and seeing opportunities here, and we talk about the smart city, the connected city. When will it all be connected? Because this will be needed. When will you have the big breakthrough? Anders, we talk about the smart city. What are your perspectives on that?
I mean, isn't it gradually starting to happen already? I mean, it's everything is more and more connected if you look on it, and I think more and more gadgets will be more and more connected. So I think we will have a gradual. I don't think you will notice this as from one day to another. It would just more or less more seamlessly be more and more connected. There is just see inside, even that has not to do with the inside a car, how it's more and more sophisticated electronics in the car, and that's connected together and will communicate outside the car as well.
And you agree? We're already there?
Yeah, we are almost there. We are already connected. Look at the bus, for example. In the past, you used to wait for the bus in the bus stop, not sure when it will arrive. Yes, you have a schedule, but you don't know if the bus will arrive on time or if you missed it because it arrived a little bit early. Nowadays, you are at the bus stop and you can see exactly when the bus is coming. Even if it gets delayed, you automatically have a sign telling you that the bus is delayed and is coming in 2 minutes because the bus is already connected to the station.
Yeah.
And it's also connected to your phone because you have the app that you can use to check.
So we're already
you
there.
can
It
see
will
that.
be
Yeah, but
more
more
and
and more connectivity should happen in the future
Yeah.
to connect more things.
So final question. What about we talk about the need for semiconductors. There's a problem in the world. We need our own suppliers, our own system. Is this a problem from a geopolitical perspective? We need more places where we make these semiconductors.
Yes, I believe so to some extent, because semiconductors is the backbone of the society now, because everything needs semiconductors. So it's on one side the requirement increases, on the other side due to many reasons, for example logistics, we have in shortage there.
Yeah.
So that's needed.
Yeah. So do we need in Europe some kind of more how to create and deliver these semiconductors within local areas?
Currently, you think if you are discussing fabrication facilities for devices, yes, usually in the past few years, people are becoming fabless, so they don't fabricate their semiconductors themselves. But this created lots of security issues, in the sense that a fabrication can modify your circuit and spy on you or control your devices. And because devices are invading our lives, now we have trust issues with the
Yeah, well, we're talking about that.
Yeah. So if you have those trust issues, it makes sense that now you need to invest on fabrication facilities that are local, that you can trust, because trust is very important.
Anders, what about manufacturing and your devices?
We don't manufacture them, since we license our IP to other fabless semiconductor manufacturers who would integrate our memory into their designs, and then they go into fabrication. But if I go back, if I may, to your original question a little bit, just a reflection, we have it's not so many manufacturers of semiconductors that exist today. And those that do exist, they are extremely huge. TSMC is the biggest one in Taiwan by far. As you asked for the geopolitical aspect, we have, and this is a fantastic company that is leading in many ways semiconductor manufacturing in the world, but we are also dependent on their ability to deliver to us. If they choose not to deliver, they have enormous leverage. If all the facilities are outside of Europe, what should Europe do in case they do not want to supply us with integrated circuits anymore?
And then we're into the political discussion, and we know what's happening in Taiwan and in China and the world politics. And in many ways, I believe it would be better if from a European perspective, that we have some kind of manufacturing closer. Is that your vision, Anders?
Yeah, this is always difficult because the costs are enormous to invest in this type of. But as an amateur, I would say that the skills needed to develop these circuits would be good to have still in Europe.
Yeah, and since we talk about collaboration, and we all do many of these things together, I believe for the world's progress, that would be great. I believe.
Yes, collaboration is important.
Collaboration is important, and as I mentioned, the semiconductor market, most of the companies, the design companies, are fabless nowadays. But if Europe collaborates together and have at least one big foundry, it's expensive, but they can fund it, and then everybody can collaborate and fabricate.
We could have it in Egypt, maybe.
Oh, well, if you trust Egypt.
Of course I do. Okay. Well, I realize I have more questions. I didn't think I would be able to, but I think it's very interesting, and I realize there's so many areas we can talk about. I hope you enjoy this if you participated and watching. And Anders, thank you so much for being with us.
It was a pleasure. Thank you very much for having me.
Well done. And Yusra, thank you so much. And Liang, well done. I hope you enjoyed as well. And once again, thanks all of you watching. I hope you enjoyed. Thank you.